lesson 11.6, day 2 of the homework. We're going to step away from calculating volume and we're going to take a look at surface area. So going back to our formula sheet, we're going to go back to the first page where we had all of our formulas for surface area. And again, if you would like to, take a picture of this with your camera, and then you'll have these formulas handy right on your phone to take a look at. Alrighty, number 2. Well, this is a very familiar figure that we've been looking at, a square pyramid. And here's how we know that it's called a square pyramid, because it has a square base. And each of the lengths of the base are 756. So this side, this base, is 756, and then when you go around the corner here, this base also has a length of 756. This base is square. The question is, what is the approximate exposed surface area? So the surface area is if I were to take a can of spray paint and spray paint all 4 triangular sides of the pyramid, how many square feet would that be? How many square feet? So what I'm going to do is I'm going to calculate the area of one of the triangular lateral faces, one of them, and then I'm going to multiply that by 4, since all 4 triangles are the same around the outside of the pyramid. So to do this, I'm going to use the formula for a triangle: 1/2 the base times the height. All right, so we need the base, and the base of the square pyramid is 756. And then you'll notice that there is a dotted line that comes down the side here, all the way down here, and that slant height is 612 feet. And so, to find the area of this triangle, I'm going to multiply 1/2 the base of the triangle is 756, and the height of the triangle is 612. And then when I get that answer, I'm going to multiply that by 4. All right, 1/2 I'm going to go ahead and put in as 0.5 times 756 times 612. So the area of one of the surfaces, one of the lateral surfaces, is 231,336. And I just noticed I put V here. Can I just go back and change that? Sorry. That would be the area. Okay, so the area is equal to, pull that up again, 231,336, and then I'm going to multiply that by 4 to get the lateral area. We call that the lateral area. So multiplying this answer by 4 gives me a total lateral area of 925,344, and we are at square feet. When we find the surface area, we are finding the number of square inches, square feet, square yards. All right, number 4 is another surface area problem where we're painting a spherical water tank. So let's do a diagram real quick here. Let's get a diagram of a sphere. which means the distance that goes all the way across is 35. But for finding the surface area, I only need to know the radius. So half of 35 is 17.5. So my radius is 17 and a half, which is half of 35. All right, so the first thing we're going to do is find the total surface area, and then we'll see how many gallons of paint that we need to purchase to paint the tank. So let's take a look at our formula sheet to find the surface area of a sphere. All right, so here we are with our surface area formula. Surface area, I'm going to come down to where I see the surface area of a sphere. And the formula I'm going to use is 4 pi r squared. All right, so we'll use 3.14 for pi. And we calculated the radius to be 17 and a half. And we're going to square that and get our total surface area. And this is in square feet. Now what I notice is that 1 gallon of paint covers 50 square feet. So the question is how many gallons do I need altogether? So how many 50s will go into this amount right here? So to find the amount of paint cans, I need to take 3,846 and a half, divide that by 50, and that will give me the number of gallons I need to purchase. So there's my answer in the calculator. Divide that by 50. And so I'm going to need to buy 77 cans of paint. And the reason why I have to round this off is because paint is only sold by the whole units. So I can't get a portion of a gallon of paint. So I'm going to have to ask for a little extra. All right, here's a fun little problem that has to do with marketing and the selling of products. And what kind of a can is more desirable for a fun-sized can? So there's 2 different designs. The gentleman on the left has a can, which is in the shape of a cylinder, and his radius is 2 centimeters. Now the young lady on the right has a can whose radius is a little bit wider, 3 centimeters. Now, the company is going to fill each can with the same amount of liquid. So the volume will be 200 cubic centimeters in both cans. So the question is, what would the heights have to be in order to hold 200 cubic centimeters of liquid? So we're going to go back again to our volume formulas, and we're looking at the volume of a cylinder. So let's get back to our volume page here. And the volume of a cylinder, we're going to use this one right here, that circle, is pi r squared times the height. The volume of each of these cans is 200 cubic centimeters. first can is 2. The radius of the second can is 3. And the question is, what is the height of each of these cans in order for them to hold the 200 cubic centimeters? So I'm going to solve both of these equations for the height. So let's simplify first. We're going to multiply pi 3.14 times 2 squared, which is 4. And then to find the value of h, I'm going to divide each side by 12.56. And therefore, my height is about 15.9. And this is in terms of centimeters. All right, over here, I'm going to simplify pi times 3 squared, or pi times 9. And then to solve for h, I'm going to divide each side by 28.26. And this is going to be an approximation. Let's try that. And this height is about 7. Right, so let's take a look at the difference in these cans. So we have a can that's a little bit taller. As a matter of fact, it's over twice as tall, but its radius is only 2. So it's a very tall, skinny can. 2, and its height is 15, almost 16. This can is a little bit wider. It's 3 centimeters, but it's only about 7 centimeters tall. Now what we know is that they both hold the same amount of liquid. They both hold 200 cubic centimeters. I'm just going to check. I want to make sure that I've done this correctly. I want to check my work and see if I've done this correctly. I'm going to go back to my original equation. Volume is pi r squared times the height. So I just want to check and make sure I calculated everything correctly. So in my first can, 3.14, the radius is 2, square it, and multiply that by 15.9. And yes, that's very close to 200. And then in my second can, 3.14, the radius is 3 squared, and we said the height of that one was about 7, and that's also very close. So I've done some rounding here, and obviously I'm not getting exactly 200, but I just wanted to make sure that I was correct in my figures. All right, so part B now, I have to decide how much aluminum I need for the 2 cans. So when they ask how much aluminum is needed, they're asking for the surface area. In other words, how much aluminum is needed to form the outside of the can. So I need to go back to my formula sheet, And I need to switch gears and go back to my page that has surface area of a cylinder. All right, and I notice that there's two formulas here. There's one here, but there's one below that's circled. And so we're going to look at this formula right here. It has values and variables that I'm much more familiar with than the formula right above it. So we have 2 pi r squared plus 2 pi r h. All right, so we're going to do each of these individually. All right, so let's take a look at our first can. Our first can has a radius of 3. And the first can has a height of 15.9. Okay, let's put all of this in. So my total surface area for the first container is I'm going to use 356.1 approximately square centimeters of aluminum to form this first can. For the second container, the radius is 2. And the height, 7. It's about 7. Now I got down to the bottom and I realized that I had made a mistake, and what I did was I put the radius for the first one into the second one. So let's go back here. We need to change a couple of things. The radius of this first can is not 3. The radius of the first can was 2. And the radius of the second can is not 2. The radius of the second can is 3. All right, but I do have the correct height. The height of the first can was 15.9, and the height of the second can was 7. So let's try this again. I'm going to get a couple different answers. All right, here we go. approximation. And now we're calculating the surface area of the second can with the correct radius, which was 3. And the height was 7. And that's about 188.4. So we can clearly see that while the two cans hold the same amount of volume, this second can uses less aluminum. So in my mind, the can that is more suitable for production would be her can. The first reason is for the reason that I just stated. Her can uses less aluminum, so it's going to be more cost effective. So the customer is getting the same amount of fluid, but it's going to be in a can that uses less aluminum. I would also say that if I were marketing a can that's a fun size, I would say that it would be much easier to package a container that looks like this. That's a little bit shorter, but has a little bit wider mouth. So there's lots of good reasons why we could come up with two justifications